previous class we saw problems on overlap save method. Today we will see the next method of linear filtering, that is overlap add method. So what we do in overlap add method is similar to overlap save method, we here also follow few procedure in order to find out the response of a system, that is y of n. So let us see what are the things which we are going to do. So in the first step, what we do is we find the length of h of n. We find the length of h of n and we denote that length as m. In the second step, we try to find out the value of n with the help of formula n is equal to 2 power m. After finding out n, what we do is we try to find out the value of l with the help of the formula n, which is equal to l plus m minus 1. Okay. The same steps we perform in overlap save method also. The starting 3 steps for overlap add and save are same. So in the next step, what we do is we compare the length of h of n with n. If the length of h of n is less than n, what we do is we pad l minus 1 zeros at the end of h of n. If the length of h of n is less than n, then we pad l minus 1 zeros at the end of h of n. So in the fifth step, what we do is we divide the input sequence x of n into subsequences such that each sequence will contain how many samples? L number of samples. That is, we divide x of n into subsequence such that each sequence will contain L number of samples. So after dividing the given input sequence x of n into n number of subsamples, in the next step we start comparing the length of the first subsequence, that is x1 of n with n. Similarly, x2 of n with n, x3 of n with n. So if the lengths are less than n, what we do is we append m minus 1 zeros at the end of all the subsequence. Okay, what we do? We append m minus 1 zeros at the end of all the subsequence which we have found out. Okay. So after appending and after making the length of the subsequence same as that of n, we try to find out y of n, that is the sub outputs, that is y1, y2 and it goes on. Okay, we try to find out the outputs of all the subdivided inputs. So once we find out y1 of n, y2 of n and for all the subsequences, what we do is we need to find out the overall output sequence. So in order to find out the overall output sequence, what we do, since we are appending m minus 1 zeros at the end of all the subsequence of the input, we overlap the last m minus 1 samples with the first m minus 1 samples of the succeeding blocks or the succeeding subsequence and we add those two samples. So the name called as overlap add method. So what we are doing? We are overlapping the last m minus 1 samples with the first m minus 1 samples of the succeeding block of the first block and we add those two overlap samples, so the name overlap add methods. So at last what we do? We try to find out y of n. Okay. So if I write the equation for the subsequences of x1 of n, x2 of n, so how will be the equation for this? So if I write x1 of n, what we do? Initially I write the sequence x of 0, x of 1 up to x of l minus 1. So from 0 to l minus 1 are nothing but the L samples of x of n Later what we do? We append zeros. So how many zeros are we appending? We append m minus 1 zeros. So this is nothing but the standard equation for the first subdivision. Similarly for the second subdivision, subsequence, that is x2 of n. So the next sample is x of L. So we write from x of L up to x of 2L minus 1. So this are nothing but again L samples of x of n. After this what we do? We append m minus 1 0. These are nothing but m minus 1 zeros. Okay. So these are nothing but the equation, and it goes on for all the subdivisions, that is for all subsequences. So writing these equations are also important. So these are nothing but the procedure which we follow in order to find out the output sequence y of n using overlap add method. Okay. Hope it is clear why the name overlap add. Now let us just summarize what we are going to do. So in the first step of overlap add method, we try to find out the length of h of n and we denote the length of h of n as m. That is the first step. In the second step, we try to find out n with the help of the formula n is equal to 2 power m. In the third step, we try to find out the value of L with the help of the formula n is equal to L plus m minus 1. Later, we compare the length of h of n with n. If the length is less, what we do? We append L minus 1 zeros at the end of h of n. Later, we take the input sequence x of n and we subdivide the sequences such that each subdivision will contain how many samples? L number of samples. In the next step, we again compare the length of subdivision of x of n, that is x1 of n, x2 of n, x3 of n with the value of n. If the length is less, what we do? We append m minus 1 zeros at the end of x1 of n, x2 of n and x3 of n and so on. So here are the equations which we will get after appending zeros. So after getting all those, we are ready with x subdivisions, that is x1 of n, x2 of n, x3 of n, and also we are ready with h of n. So now I need to find out y1 of n, y2 of n and y3 of n. So we try to find out y1 of n, y2 of n, y3 of n with the help of matrix method of circular convolution. Later, after finding out y1 sequence, y2 sequence, what we do is we overlap the last m minus 1 samples of the first sequence with the starting m minus 1 samples of the succeeding sequence and we add those overlap samples, so gives us y of n. So this is the procedure of finding out overlap add method, that is we try to find out y of n with the help of overlap add method, and the figure for all this procedure, that is how we divide the input block, how we concatenate the output, that is how we overlap and add the output in order to find out y of n, is as shown in figure. So this figure is very important. If you draw the figure with the equation, you can fetch full marks. After this, now we will see problems on overlap add method and we will learn how to solve problems using overlap add method. Now let us move on to the first problem of overlap add method, and the question is, a long sequence x of n is filtered through filter having h of n which is equal to 1, 2 to yield y of n if x of n is equal to 143074 minus 7 minus 7 minus 1 343. Compute y of n using overlap add method. Use 5-point circular convolution. So now let us proceed with the problem. The first step what we need to do is we need to find out the length of h of n. So we denote the length of h of n with the variable m. So what is the length of h of n? We have 2 samples, so the value of m is 2. Okay. And in the question they have indicated use 5-point circular convolution. So there is no need to find out the value of capital N. Instead, you can directly write n is equal to 5. Why am I writing this? Because they have directly given in the question. If it is not indicated in the question, what you need to do? We need to find out the value of n with the help of the formula n is equal to 2 power m. Okay. Now writing m and n is done. Now let us try to find out the value of L. For that, the formula is n, which is equal to L plus m minus 1. N value is 5, which is equal to L plus 2 minus 1. So 2 minus 1 is 1. Moving this to this side, 5 minus 1 becomes 4. So the value of L is 4. Okay. Now in the next step, what I need to do? I need to divide the input x of n into subsequences such that each sequence will contain how many samples? 4 samples. So let us start dividing. Okay. So 1, 2, 3, 4. So this becomes x1 of n. Then this is x2 of n. So this is x3 of n. Okay. Let us rewrite that. That is x1 of n is equal to 1, 4, 3, 0. x2 of n is equal to 7, 4 minus 7 and 7. x3 of n, which is equal to minus 1, 3, 4, 3. Okay. Now in the next step, I need to compare the length of h of n with n. Okay. The length of h of n is 2, but the value of capital N is 5. The lengths are not matching, it is less. So I need to append L minus 1 zeros at the end of h of n sequence. So the value of L is 4. 4 minus 1 is 3. So I need to append how many zeros? 3 zeros to h of n to make its length equal to capital N, that is 5. So if I append zeros and write, h of n will be equal to 1, 2 followed by 3 zeros. Okay. So these zeros are nothing but you are appending L minus 1 zeros to make the length equal to 5. Now appending zeros for h of n is done. Now let us compare the length of x1, x2 and x3 with n. So the length of x1 is 4, but the value of n is 5. So what I need to do? I need to append m minus 1 zeros at the end of all the subsequences, because the length of all the subsequences are 4, it is containing 4 samples. So what is the value of m? The value of m is 2. So how many zeros should I append? M minus 1. So 2 minus 1 is 1. So I need to append 1 0 at the end of each subsequence. So what will be your x1 then? x1 of n will be equal to, so the first sequence will be 1, 4, 3, 0 and 0. So what am I doing? I need to append m minus 1 zeros to all the subsequences. So I am appending the value of m is 2. So 2 minus 1 is 1. So I am appending 1 zeros at the end of sequence. So here m minus 1 0, m minus 1 0, m minus 1 0. So x1 of n will be 1 4 3 0 0. x2 of n will be 7 4 minus 7 and 0. x3 of n will be minus 1 3 4 3 and 0. Keep one thing in mind, the procedure for overlap, add and save are same until this step. All the steps are common for both the methods, but appending zeros and dividing the values of input for both are changed. Keep that thing in mind, don't get confused between overlap, add and save. So now we are ready with the subsequences as well as h of n. Now let us try to find out y of n using circular convolution. So we know y1 of n is equal to x1 of n circular convolution with h of n. So this is equal to, what is x1 of n sequence? It is 1, 4, 3, 0 and 0. Now if I shift this to the top as an top element, so it comes here, shift 1 here. So it is nothing but the same matrix method which we have already studied. Okay, 3 0 0 1 4 4 3 0 0 1. So we are done with x1 of n matrix. Now what is h of n? H of n is nothing but equal to 1, 2, 0, 0 and 0. So this is equal to, so I need to perform matrix multiplication. So if I perform matrix multiplication, 1 into 1 is 1, 0 multiplied by 2 is 0, 0 into 0 is 0, 3 into 0 is 0, 4 into 0 is 0. So we are left out only with 1. So the first element is 1. Again coming to the second row, 4 into 1 is 4, 1 into 2 is 2, 0 multiplied by 0 is 0. So we get only 4 into 1 plus 1 into 2. So 4 plus 2 is 6. So 6 is the second element. Similarly, coming to the third row, 3 into 1 is 3, 4 into 2 is 8. So 3 plus 8 is 11. Okay, we are done with that also. Moving on to this, 1 into 0 is 0, 3 into 2 is 6. Rest of the elements are 0, 4 into 0 is 0, 1 into 0 is 0. So this is also 0, we get only 6. Again moving on to the last row, 0 into 1 is 0, 0 into 2 is also 0, 3 into 0 is 0, 4 into 0 is 0, 1 into 0 is 0. So the last element is 0. So this is the first matrix which we are getting, that is we found out y1 of n. Similarly, I need to find out y2 of n and y3 of n using matrix method, that is y2 of n will be equal to x2 of n circular convolution with h of n. This is equal to, what is y2 of n? It is 7, 4, minus 7, minus 7 and 0. Let us shift this. 0, 7, 4, minus 7, minus 7, minus 7, 0, 7, 4, minus 7. Move this to the top position, minus 7, minus 7, 0, 7 and 4. So 4, minus 7, minus 7, 0 and 7. And finally, what is h? H is 1, 2, 0, 0 and 0. Okay. We are done with h2 of n and h3 of n. Now I need to multiply. So if I multiply, 7 into 1 is 7, 0 into 2 is 0, minus 7 into 0 is 0, minus 7 into 0 is 0, minus 7 into 4 is also 0. So what is the value which we are getting? The first value is 7. Okay. Similarly, if I move on to the next value, that is 4 into 1 is 4, 7 into 2 is 14. So 14 plus 4 is 18. Moving on to the next one, minus 7 into 1 is minus 7, 4 into 2 is 8, 8 minus 7 is 1. Moving on to this row, minus 7 into 1 is minus 7, minus 7 into 2 is minus 14, which gives us minus 21. Okay. Moving on to the last one, 0 into 1 is 0, minus 7 into 2 is minus 14, rest of the elements will tend to 0. So this is minus 14. So y2 of n is also completed. Now I need to find out y3 of n. So how to find out y3 of n? We know y3 of n is nothing but equal to x3 of n circular convolution with h of n. So what is x3? x3 is nothing but minus 1, 3, 4, 3 and 0. So shifting the elements, 0, minus 1, 3, 4, 3. Again it is 3, 0, minus 1, 3, 4. 4, 3, 0, minus 1, 3. 3, 4, 3, 0 and minus 1. Next I need to multiply h of n, that is 1, 2, 0, 0, 0. Now I should perform matrix multiplication. So if I perform matrix multiplication, minus 1 into 1 is minus 1, 0 into 2 is 0, 3 into 0 is 0, 4 into 0 is 0, 3 into 0 is 0. So the value which we are going to get is minus 1. Okay. Moving on to the second row, 3 into 1 is 3, minus 1 into 2 is minus 2. So rest of the element will tend to 0. So 3 minus 2 is 1. Moving on to the third row, 4 into 1 is 4, 3 into 2 is 6, rest of the element tends to 0. So 4 plus 6 is 10. So the fourth row, 3 into 1 is 3, 4 into 2 is 8, rest of the element tends to 0. So 3 plus 8 is 11. The last row, 0 into 1 is 0, 3 into 2 is 6, rest of the elements are 0. The value which we are getting is 6. So what we did, we had 3 subsequences, that is x1, x2 and x3. So we got 3 output sequences, that is y1 of n, y2 of n and y3 of n. Now what I need to do, I need to overlap the last m minus 1 samples of y1 of n with the first m minus 1 sample of y2 of n. Again I need to overlap the last m minus 1 samples of y2 of n with the first m minus 1 samples of y3 of n, and I need to find out the final output, that is y of n. Okay. So hope it is clear how to find out until this step. Now let us see how to find out the overall output sequence. I have tabulated the values of y1 of n, y2 of n and y3 of n here. Now what I need to do, I need to start overlapping and adding. So first I will write y1 of n, that is 1, 6, 11, 6 and 0. So what is the value of m? The value of m is nothing but the length of h of n. So it is 2. So 2 minus 1 is 1. I need to overlap one sample, the last sample of y1 of n. So this is the last sample with the first m minus 1 sample of succeeding block. The succeeding block is y2. So again m minus 1 is 1. I need to overlap this with this one. So here comes 7 followed by 18, then it is 1 minus 21 minus 14. Now again I need to overlap the last m minus 1 sample of this particular block with the first m minus 1 sample of the succeeding block. The succeeding block for y2 of n is y3. So again m minus 1 is 1. I need to overlap this with the last m minus 1 sample. So if it is m minus 1, so this is the last sample. So I need to overlap minus 1 with minus 14. So the rest will be 1, 10, 11 and 6. So overlapping is done. Now I need to add the sequences. So if I add the sequence what we get is nothing but y of n. So here we don't have anything. So write directly 1. So then write 6 also directly because we don't have any elements here. Write 11 directly. Write 6 directly. Now these two samples are overlapping, so I need to add. So if I add 0 with 7, we get 7. Again write 18 as it is, write 1 as it is, write minus 21 as it is. So these two samples are overlapped. Now add these two samples, that is minus 14 minus 1 is minus 15, 1, 10, 11 and 16. So this is nothing but your y of n. So what we did, we overlapped the samples, m minus 1 samples, and we added, so the name overlap add method. Okay. Now in order to verify the length of y of n, the formula is same as that of overlap save method. So the formula for that is length of y of n, which is equal to L1 plus L2 minus 1. You can take L2 as m also. L1 is nothing but the length of x of n, L2 is nothing but the length of h of n. So let us find the length of L1, that is x of n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So L1 is 12. So L2 is nothing but the length of h of n, which is also called as capital M. So the length is 2 minus 1. So 12 plus 2 is 14, 14 minus 1 is 13. So the length of y of n should be equal to 13, which is nothing but it should contain 13 samples. So let us see whether it has 13 samples, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, it is having exactly 13 samples. So like this you can verify the length of y of n. If you have more number of samples, if it is exceeding 13, you can delete the remaining samples and rewrite only 13 samples. Those 13 samples constitutes the output for the given input. Okay. So, this is how we can find out the response of a filter with the help of overlap add method. So, this was the first problem. So, let us move on to the second problem and see how to solve that. The next problem in overlap add method is they have given x of n sequence and h of n sequence and they are telling us to compute y of n with the help of overlap add method, and they are telling us to use how many point circular convolution? 6 point circular convolution. So, first I need to find out the length of m. So, m is nothing but length of h of n. H of n is having 4 samples. H of n is having 4 samples. So, m is equal to 4. Similarly, n value is directly given. So, write the value of n as 6. They have told us to compute 6 point circular convolution. So, then try to find out L with the help of formula. N is equal to L plus m minus 1. So, n is 6, which is equal to L plus 4 minus 1. 4 minus 1 is 3, 6 minus 3 is 3. So, L will be equal to 3. So, in the next step, what I need to do is I need to divide the input sequence x of n into subsequences. So, and each sequence should contain how many samples? 3 samples. So, let us start dividing. So, this is the first one, second, third, fourth, fifth and the last one. Let us tabulate all those. That is, x1 of n will be equal to 1, 2, 1. x2 of n will be equal to minus 1, 3, 0. x3 of n will be equal to 5, 6 and 2. x4 of n will be equal to minus 2, minus 5, minus 6. x5 of n is equal to 7, 1 and 2, and finally x6 of n is equal to 0 and 1. There is no one more sample. What I can do, instead of that you can directly add 0. Okay. Now I need to check the length of h of n with the length of n. So the value of n is 6, but h of n is having how many samples? 4. The lengths are not matching. What I need to do? I need to append zeros. So how many zeros should I append? I need to append L minus 1 0. The value of L is 3. So 3 minus 1 is 2. So I need to append 2 zeros so that the length of h of n will be equal to 6. So if I append zeros and write, h of n will be equal to 1, 2, 3, 4, 0 and 0. So this is nothing but L minus 1 0. Okay. Now let us start checking the length of h1 of n. So the length of h1 of n is 3. x1 of n is 3. So this is not matching the length of n. So I need to append how many zeros? M minus 1 0. The value of m is 4. 4 minus 1 is 3. So how many zeros should I pad to all the subsequences? 3 zeros. So let us append zeros at the end of each subsequence. So it becomes 1 2 1 triple 0. x2 of n will be equal to minus 1 3 0 0 0. x3 of n will be equal to 5 6 2 0 0. x4 of n will be equal to minus 2 minus 5. So this has to be 3 zeros. Minus 5 minus 6 0 0 0. So x5 of n will be equal to 7 1 2 0 0 0. So x6 of n will be equal to 0 1 0 0 0 0. Now we are ready with the subsequence. Now let us start finding out y value. So y1 of n is equal to x1 of n circular convolution with h of n. So this will be equal to, what is x1 of n sequence? It is 1 2 1 triple 0. Start shifting 0 1 2 1 0 0. 001210, 000121, 1000112, 21001. What is h of n? H of n is 1, 2, 3, 4, 00. Now we should start performing matrix multiplication. 1 into 1 is 1, 0 into 2 is 0, 0 into 3 is 0, 0 into 4 is 0, 1 into 0 0, 2 into 0 is 0. So what we are getting? We are getting only 1. Moving on to the next row, 2 into 1 is 2, 1 into 2 is 2, rest of the element tends to 0, so 2 plus 2 is 4. The third row, 1 into 1 is 1, 2 into 2 is 4, 1 into 3 is 3, so we get it as 1 plus 4 plus 3, so 1 plus 4 is 5, 5 plus 3 is 8. So the next row, 0 into 1 is 0, 1 into 2 is 2, 2 into 3 is 6. Next, 1 into 4 is 4, so we get it as 2 plus 6 plus 4. So 2 plus 6 is 8, 8 plus 4 is 12, so the next value is 12. Similarly, moving on to this, 0 into 1 is 0, 0 into 2 is 0, 1 into 3 is 3, 2 into 4 is 8, 8 plus 4 is 11. So the last sample, the first three values are 0, multiplied by the element gives us 0, 4 into 1 is 4, the last one is 4. So we found out y1 of n. Similarly, we need to find out y2 of n, y3 of n, y4 of n, y5 of n and y6 of n in order to find out the final output. So what I did is, I have shown how to solve the circular convolution using matrix method. I want you people to follow the same procedure in order to find out y2 of n, y3 of n, y4 of n, y5 of n and y6 of n. I have directly written the sequence which we are going to get. What I need to do, I need to overlap the last m-1 samples of the first sequence with the first m-1 sample of this succeeding sequence. So for that, the value of m is 4. So 4 minus 1 is 3. I need to overlap 3 samples. So I have written all the values. So I will start overlapping. That is 1, 4, 8, 12, 11 and 4. m-1 is 3. So I need to overlap 3 samples. So the next 3 samples are -1, 1, 3, 5, 2 and 0. So y3 of n is nothing but 5, 16, 29, 42, 30 and 8. So y4 of n is -2, -9, -22, -35, -38 and -24. So next I need to overlap the last m- samples of y5 of n, that is 7, 15, 25. So next it is 35, 10 and 8. Later it is 0, 1, 2, 3, 4, 0. The value of m-1 was 4. I have overlapped 3 samples, that is last m-1 samples of first sequence with the first m-1 sample of the next sequence. Again last m-1 sample of this one with the first m-1 of y3 of n. Similarly for all the samples. Now what I need to do, I need to add the overlapped samples so that we get y of n. So y of n will be equal to, so there is nothing between 1, below 1 I will write it directly, write 4 as it is, write 8 as it is. So 12 minus 1 is 11, 11 plus 1 is 12, 4 plus 3 is 7, 5 plus 5 is 10, 16 plus 2 is 18, 0 plus 29 is 29, 42 minus 2 is 40, 30 minus 9 is 21. So 8 minus 22 gives us minus 14. Similarly, minus 35 and 8 gives us minus 28, and minus 38 plus 15 gives us minus 23, minus 24 plus 25 gives us 1, 35 plus 0 is 35, 10 plus 1 is 11, 8 plus 2 is 10, 3, 4 and 0. Now let us check the length of y of n, whether it is correct or wrong. So length of y of n will be equal to L1 plus L2 minus 1. So L1 length is 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15, 15 plus 2 is 17. So the value of L1 is 17, the value of L2 is 4 minus 1. So 17 plus 4 is 21, 21 minus 1 is 20. We get this as 20. How many samples y of n should contain? 20 samples. Let us check whether it is having 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is one extra sample. We need to leave that sample and we need to write y of n. Therefore, y of n is equal to 1, 4, 8, 11, 12, 7, 10, 8, 29, 40, 21, minus 40, minus 28, minus 23, 1, 35, 11, 10, 3 and 4. So this is nothing but the sequence y of n. So this is how we can solve problems using linear filtering techniques called as overlap add method and overlap save method, and we can find out the output sequence of any filters. So these are the two methods which is very important with respect to exam point of view. So concentrate on these problems and try to solve n number of problems. So in the next class we will try to study what is fast Fourier transform and what are the different techniques in fast Fourier transform. Thank you for today's session.